Oh, thank you. Okay, cool. All right, now we have the recording. That's great. So that's basically what the VQL looks like. And oh, okay. So this is the structure. Okay, so now we have a recording. That's cool. So we should be able to access it later. All right, great. So we're going to have a bit of we're going to play with some queries, and we're going to write some queries, and then we can so we're not going to go into a lot of detail with the syntax, but we'll see if we can sort of figure it out as we go along, because I didn't want to spend too much time on the actual language too much. But in order to play with it, the easiest thing that we can do is use this thing called a notebook. And a notebook is like an interactive document that you can use to create queries or analyze queries. And in Velociraptor, we use that to post-process queries, to post-process data or to explore data. So it's like if you've ever used something like Jupyter Notebook or something like that, it's similar idea, right? So you can run the notebook yourself. So let me just show you how that works. So we'll go over to there's our Velociraptor, and you can see that there is this notebook screen here, so you can enable that. And when you first start off, of course, there's no notebook, so we can create one. So we just push this plus, creates a new notebook, and we can call it, give it a name, test, and a description. This is a test, for example. And then we just hit submit, and you'll see that it just creates. This is called a notebook, right? Here we can have a list of them, but this is the notebook down here. And at first, it sort of looks a bit confusing because it's like, well, we just call it test and we're just seeing this thing. What am I supposed to do with it? And so for some people find it confusing. So, yep. So when we click on this, when we click on the text, that brings it into focus. And when it brings it into focus, we can see these controls. So this is called a cell. So these are cells, and you can create more cells underneath each other. And over here, we can see there's a type. So this is the cell type. When you click edit, this is the edit. You can see there's a type. So this is a markdown cell. You can change it to Vql Cell, but we'll just leave it as markdown. So here so this explains what we're seeing here. What we're seeing is like this markdown. And you can add whatever text you want here. Item 1, item 2. The idea is that you can just use that as more or less documentation. So it's not super interesting, here, but what we can do is we can also add a Vql cell. So when you click that plus button here, you can add another cell. And we can click Vql, that adds the next cell. So this is now, you see that's the second cell that's sitting underneath that first cell. So another cell. Now, if we click the edit button again, then we can see this is a type. The type of the cell is Vql. And so here we can put queries. We can put any query we want. So we'll start off by, and again, if the font is too small, you can click that button here to change the font and the colors and things like that. So let's start off with a very simple query. Select star from info. So info is like the hello world. Now, as you'll see that as I'm typing it, it gives me suggestions. So this is the suggestions, and each of those, all the plugins that start with I, right? So if info interfaces, that kind of thing. So I can basically see what they are, what they do. Info. And store it, right? So now this basically, you can see that when I click the save, it ran the query, and this is the output, right? So it basically writes like a table, so we can see the table. So let's have a look at, it's the same thing that we've seen before. We have like, a whole bunch of columns. It tells us a bit about the machine. But the thing that you have to remember is that when you are running something in the notebook, you're actually running this query on the server. So this is the server, right? But it's also the client, but in a real deployment, this will be the server, right? So in the notebook, you're always running it on the server. it's the same thing. It's the same VQL. You can use it the same VQL on the server and also on the endpoint. But when we're doing it in the notebook, it's always on the server. So this is how we evaluate queries. And then now we're going to talk about some of the VQL and start to apply them in a real scenario, in the real world scenario. So this is the first example. It's just bringing up the notebook and writing a simple query. So, we can see the notebook, we can see the query. We can see down here, it's got some messages. And if we have any query log, we've got here. So if we have like a syntax error or something, it tells us that here. This is adding a new notebook. Click on that. This is editing. So we can edit, and then we can add a new cell over here. Once we add a new VQL cell, then we can start to type a VQL in here. And you can see that the completion is going to help us out. Here, oops. Okay, so we can talk about VQL syntax, and we do have in the training like a whole 2-hour session about the syntax in a lot of depth, but we're not going to have time to do that. So what we're going to do is I'm just going to give you a flavor of what we can do with VQL and encourage you to go back to our documentation and other training material to learn a bit more about it, so that you can you can understand VQL in much more detail. But for this exercise, we're just going to do some more practical stuff. So the first thing that we're going to look at is the bits service. So this is a fairly common. So the bits service is the background. It's a background downloading service, and it's used by Windows to download usually Windows updates, right? But it can actually download anything really, and this is actually quite often used by attackers to for persistence and also for escalation. So here's an example of something that would be, a malware kind of type of activity, right? Like normally Bits admin is used to download Windows updates or Office updates, something like that, right? But you can see that you can just download anything with it and you can save it anywhere. Now, the reason that this is attractive to attackers is that if you have an EDR that is looking for network connections, and it's like, hey, this strange executable is making network connections out to a strange site. That's suspicious. But if it's the Bits admin, so it's Windows itself is connecting out, that's usually whitelisted, right? So usually, if you use that, then a lot of the EDRs will miss it, right? Because they'll whitelist this Bits admin, right? So this is why a lot of the attackers use it. Anyway, all you have to do, just copy that, and let's open another, another administrative command shell like this, and I'm just going to go to users mic downloads to just keep things in the clean area. Okay, cool. So over here, I'm just going to run this command, right? Except it's user mic. That doesn't matter. User mic. Okay, so what this is saying is it's creating a Bits admin, a download job, right? So the download job is going to be created, and then Bits is a service in Windows, and it's going to say, go off and grab this URL and save it here, right? So this could be a malware or a malicious URL, whatever. I mean, in this case, we're just going to download some file, right? So off we go. If we just run it, then it's going to go off, and it's going to basically set up a download job and download this thing. So you can see that here's the file, right? So it downloads the file. You can also do things like in Bits admin, you can tell it, run this file after you download it. And this is where you can get escalation and execution and all this kind of cool stuff, right? So this is a fairly common misbehavior, because usually it's not sort of supposed to do that, right? So what we're going to try and do is try and find out about it, right? So usually what we're going to do is there'll be a log somewhere in the event log that Bits admin did something like this, right? So we're going to look at event log. We're just going to look at the event viewer so we can see that event log message, right? That we just ran it. So usually for the Bits admin, you know, it has its own log. It's in application and services. I don't know if this font is too small for you guys to see, but hopefully you'll be able to see this log message. Come on. Windows Event Viewer isn't the fastest of applications. So we'll just give it a second. Come on. Come on. Here we go. All right. Okay, so it's going to be Microsoft, Windows. And then over here, you can see a whole bunch of different logs. And one of them is going to be Bits client and operational. Right, so there we go. And here, we're going to see the log messages that come from the Bits client. Let me just make this a little bit bigger. Okay. And you can see that there is there's a whole bunch of messages that come from this thing that I just ran, right? So it's got transfer job is complete. It stopped transferring it. This is the URL where I fetched it from, right? So this could be a malware URL. And then we have, you know, another URL. This is where it started. So we know when it started, we know when it's finished. And, you know, we've got this log basically says when I created the job, right? So I created the job, and this is really important because it's also telling me, you know, who created it, right? So I can tell, you know, which user it's created, and if this is malware, then you'll know. So this event log is giving me a lot of very critical information about this Bits client, right? And it's enabled by default, so I can see this. Now, a lot of EDRs they just work by forwarding this log, right? So this log can be forwarded to a SIEM or something like this, and then hopefully there'll be some kind of rule detection on that SIEM that will say, hey, someone's run this Bits admin, that's really bad, alert, you know, and then we'll have escalation and detection, right? So this is kind of the industry, how the industry works today. We are relying a lot on event logs for a lot of stuff, right? Problem is that event logs are not actually very reliable because you can just disable them, right? So so this is what I wanted to show you guys. So all you have to do, so here we are, right click, disable log, right? Now what I'm going to do is I'm just going to clear this so it's not confusing. I'm going to clear this log, clear log. Now, when I clear this log, right, if I run this Bits client again, it's the same thing. So we've seen it before, just not this one, this one. So I'm running this Bits client again, the same as before, and I'll have no logging because I disabled the log, right? That's really all it takes, right? It's not that complicated. So if I do this, you know, refresh, whatever, right? The log is disabled, right? There's no events in it. So that's all it takes, right? So an attacker, they're about to do something, you know, suspicious, and they're like, yep, right click, disable log, off we go, right? And if your EDR relies on log forwarding, you're completely blind. You have no idea, right, that this is happening. So you won't see it. It's actually quite easy to do. So it's relying on logs for detection is not great. And so this is what we're going to talk about now. So this is a problem, right? So now, how do we figure out what, you know, whether the logs have been disabled? How do we know that? See, we just click disable log, it disables it. So how do we know, like, what actually is going on under the hood, what's going on, right? So whenever we want to know, in Windows, what is going on, the best tool is to use this thing called procmon. So we can go to this procmon, and procmon is just a tool that we can use to essentially like figure out, which files are open or whatever. So I'm just gonna download it from sysinternals. So that's the executable, and it's going to be in the downloads directory. So actually, I'm going to open this one. Yep. Yeah. Okay. So here I've got my procmon, right? So I'm going to run it, procmon, and it's a pretty cool application, right? It just runs off and it starts to detect all kinds of file access and registry access, right? It's just running along, right? So let me just do that again. So if I stop it, then I'll go to the event viewer, and if I enable the log or disable it, and then I stop capturing, and I can see what's going on in the registry with regards to, logs. Because obviously when I enable or disable it, something's going to change in the registry. I have no idea what, but something will change. Some settings are going to change, right? So I want to figure out what settings are changing so I can maybe detect them, right? So usually there's going to be a lot of, file access, you see registry access, whatever, right? So I went in, I started the capture or the recording, and then I went and disabled the log or enabled the log, and hopefully that would change the right key in the registry. And then if I look at it, then I'll be able to see what key was changed. So I've got a whole bunch of processes that are doing stuff on this, there's SVC host and all kinds of stuff, right? And I don't know which key it is that is changing, but usually you can basically, sort of either eyeball it, or you can also filter. So, basically it's going to be, so it's going to change something. So it will write a value. So you can actually go and filter it, add a filter. Like, I don't know exactly which value, but I know that the operation, okay, so operation, so this one, see how it's reading the key or writing the key. So I'm going to basically and then I can look at the operation, and it's not a query because it's going to change the key, right? So change the value, right? So it's going to be not delete value, but it's probably going to be let's see, enum value. It's not enum. Query value. It's not query. It's probably going to be set value, right? Because it's going to set the value. So something I did there is going to write to the registry. And when you write to the registry, you set the value, because that's kind of what writing means, right? So, oh yeah, so add them. And it's going to basically filter all of that junk that we've seen there from procmon into basically only the things that change the registry that wrote to it. So it's a lot smaller, see, and it's coming from a lot of processes, and we can see all kinds of stuff going on, right? That's not really relevant. But very quickly, we can see somewhere. Did I capture it? I don't remember if it doesn't look like I captured it. Oh yeah, here, there. So there is one value here. I don't know why the font is very, very small, but anyway, I don't know if I make it bigger. Don't know. You can see that there is this HKey local machine software, Microsoft Windows current version, WiniVT channels, Microsoft Windows Bits client operation enabled, right? So this is really cool. I can have a look at that registry key and see what's going on there. So this, copy, start regedit. Yep. And go to that value, check it out, what's going on there. So here I have that, right? And I can see that I have enabled, right? So this is the logs enabled. And if I go over here and I disable it again, right click, disable log, right? And then I just do a refresh here. it's gone to 0, right? So that's it, right? So that's key, this value here inside of the registry controls whether the log is enabled or disabled, right? So it's pretty straightforward. So now I can say, hey, so now I know this is the registry setting that controls when the logs are enabled or disabled. So I want to know which logs on this system are enabled or disabled. And you can see that the way that this key works is that all of these things are just different logs, right? And then they all have either enabled or disabled, right? So, some of them are naturally 0 and some of them are 1. So we've just figured out how it works, right? This is just like we figured it out. So now what we want to do is write some Vql to detect it. Okay, so let's have a look at, let's go up, just scroll up and write some Vql. So what we're going to do is let's write the key. So this is the key, right? H key local machine. Let's put it in a variable, right? So it's going to be the value. What should we call it? I don't know. Value. Now in Vql, if you put 3 quotes, then it's like a row string. So you don't need to escape those backslashes. Otherwise, I mean, it doesn't matter. You can use straight backslashes, or you can use normal quotes, but then you'll have to escape them. So this is the value, that's in the registry. And then the only other thing is that we have to use H key local, because Velociraptor uses the full name for the key, right? So H key local machine, software, Microsoft, Windows, current version, channel, Windows. Great. So now what we want to do is we want to read that value, right? So we want to read it. So we're going to use glob. Right? Glob is basically a plugin that lists directories. So just like a glob, right? So when you are in a file system, you do an ls star. So you can use wildcards. So we're going to use glob. Now in the notebook, whenever you press question mark, then it gives you suggestions of what you can use here. When you're, and it's context aware, right? So if you're inside of the parentheses here, then it tells you what parameters you're allowed to give in this plugin, right? So what parameters this plugin gives. So we're going to press, we're going to select globs, and then we're going to pass this, value in there. Now, what we're doing is we're trying to read the registry. Normally, glob is used to read from the disk, right? So we can have like a C column, users / star or whatever, right? But in Velociraptor, we can use something called an accessor to tell it what to access, right? So we want to access the registry instead of the file system. So registry, right? So that just basically, it's like an accessor is like a driver that allows us to get stuff from the registry. So this basically says, grab this file out of the registry. So we'll just run this thing. Oh, sorry. But we don't want to just grab the Windows bits, because this one's actually just for Windows, just for bits, but we want to get it for all of the logs. So let me just replace that with a star. So that will get all the logs, right? So it's like a wildcard kind of thing. So when we do this, then it's basically going to go through and it's going to tell us this. It's basically selecting information about each of those values, right? From here. So it basically goes through each one of those, right? And then looks at this enabled value and telling us about each of those, right? So this is the type of information that it's returning. And what I'm going to do is I'm just going to click this binoculars so you can see it a little bit better. So we have a name, we have modification time, and of course in the registry the modification time goes with the key, right? So that's the key that the value is in that has the modification time, which is not always really the time when the value is changed, because it depends on things. But then we have this data column, I guess, that has the actual value of this value, right, of this registry value. So it's a D word, and the value is 0 in this case, right? For this particular one. And then, it could be 1 for something else or whatever, right? And then we have, other ones that are not so important. So from here, what I actually care about here is, well, let's see. So I want to know, so the name is the name of the value, but it's always the same, right? It's always enabled. So I don't care about it that much. I care about the full path, right? So there's the full path. So then I'm just going to go over here and say, okay, full path. And then I also have the mod time, because that is, that could give me a clue as to when it was changed. So forensically, it's important. And then as we have, or the M time, it's the same thing. And then we've got the data.value. So data.value, that's going to give me this 0, right? So data.value. Okay. And let's see. So the first thing I do is just reduce the number of columns. So I don't want to have quite so many. So let's see. Right. So we've got, so that's looking a lot better, right? It's looking better. This is the value that I'm looking at, each one, right? And then this is the modification time of each one. That's fine. And then it's 1 or 0, right? So it's enabled or disabled, right? That's the value. So that's pretty good, except that I'm actually more interested in this part here. I don't really care about this side and this side, right? So what I'm going to do is I'm going to just like strip off that thing, and I just want to get this part of the, because that's the key, right? So I'm going to use dir name. Dir name returns the directory of a path, right? So I'm going to put a question mark to see what parameters dir name takes. So it takes a path. Okay, great. So let's do that. So now, if I do that again, that essentially drops the enabled part off, because it just shows the directory, right? So now we're almost there. We just need that last part. We don't care about this first part. We just need that second part. So what we're going to do is we're going to use the opposite of dir name, which is base name. Base name is the, so when you have a path, the base is the top part, and then the directory part is the bottom part, right? So the base name is essentially the top part. So here's the path, right? So now, so this is basically going to take the path. It's going to drop the top part off, and then drop the bottom part off, and just give us that, that middle part. So that is the name of the key, right? In that of just that key, right? So that is kind of what we want, because that's the name of the log that is either enabled or disabled. So now we have this. So now you can see this is the column name, which is essentially the function, right? But it's not that useful. We need to know what it is. So let's rename it as log name, right? So that's the log name. So then that is the column name, and then the modification time, and this is whether it's enabled. So let's change the name as enabled. Okay. So there's our query, right? So once we do that, then we can see if it's enabled, if it's modified, or if it's which log is enabled and which one is not. And that's really what we want to do. That's our detection. So that is actually what we want to do. Let me, so let's go back to recap our slides. So we did this procmon. We figured out how to detect this behavior. We figured out which key it's in. We took the key, and then we did a glob to find out the enabled value, what the value is. And then we went through and we wrote some query. And then our query basically told us whether the component, the log, is enabled or not. Right? So that's kind of how we created our own VQL. So now the problem is that we want to be able to collect it from the endpoint, because remember, when we're running the query here, what we're doing is we're only able to run this on the server, right? So which is this Windows machine. But realistically, we need to be able to collect it from the endpoint. So what we need to do is take that query and encapsulate it in the artifact in the YAML file, and then we can use that and collect it. So let's open up another tab, right click, open new tab. And here is our artifact, management screen. So we've seen that before, right? Where we can basically look at the different artifacts, we can search for them, and we can look here. What we're going to do is we're going to create a new artifact, right? So we press this plus, and what it will do is it will show us, this is a template of what an artifact is supposed to look like, just to make it a bit easier for us to write a new artifact. So it starts off with a name, and it has to be starting with custom, right? The name has to start with custom because it's a customized artifact. So we're going to call it windows.logs.enabled. That doesn't really matter what the name is, but it's just something that helps us find it. And then we put a description, discovers if the Windows log is enabled, something like that. And then we can have the type of the artifact, and the client is a default. This means that the artifact is going to be running on the client, is collecting from the client. So that's what we want. So then the next thing that I do is I normally just jump straight in here. And then I have a precondition. The precondition basically controls whether this runs on Windows or Linux. So it basically, it's just a query, and if the query doesn't return any rows, then it doesn't run the artifact at all, right? It's a no-op. So it helps us to safely be able to run this artifact on pretty much any machine, because it kind of whitelists it. Only Windows machines will actually run it. So I'm going to set the precondition to that. And then I'm going to copy the query. So all I do is I copy from here, right click, copy. And then I go over here, and you see here, this is as I said, it's a template, right? So it just tells us like a sample query. This is the one that we did before, our sample query. So I'm just going to replace it with this new query. And I have to kind of tab it over because this is still YAML, right? And so this is my new query, right? And I can format it, in some way. Like this, the white spaces don't really matter, if you don't want, you can format it however you like, right? So, and then this is now the artifact. That's really all it is, right? So it's just about, artifacts are just about copying the VQL and plonking it into a YAML file. And look, the parameters, we don't really need a parameter right now, so we can just even delete that, doesn't matter. And then we're ready to go, right? So when we save it, then this custom one, so that's the prefetch one, this one, this is the one we've just written. So that now becomes an artifact in the system, and we can use that to collect it from the endpoint, right? It's basically can be just totally used. So now I'm going to find my client again. So I have my client, click the collected, and I can simply collect that one. So it's not very, it's the same as any other artifact, but I just wrote it from scratch, right? And I did it in order to detect a new kind of threat. So I do it, it takes 0.67 seconds to do the thing, right? Because it's just querying the registry and pulling out the keys. And here we go, right? So this basically tells us what we've just discussed, right? Whether they're enabled or disabled. So that's cool. So this allows us to essentially get like a snapshot of which logs are enabled, which logs are disabled on the system, right? So that if things change, then we're like, hey, something happened there. Why are these suddenly changing? Or maybe we could do baselining to check, whether these logs are supposed to be enabled or not. If they're not enabled, why not? So there's a lot of uses for this kind of example. Cool. But anyway, the point is that the process that we went through is the same, right? So we went through the same process. We looked at an anomaly. We figured out that there is some kind of something fishy going on. We figured out how to detect it. How do we detect whether the log is is misconfigured or is not correct? Then we wrote VQL, tested it, and then we turned that into an artifact. And now we can go ahead and hunt for it. So there is this process. We're doing this process all the time. And this is the workflow pretty much for everything. We start off with some idea, had an idea. We explore the idea by writing queries in the notebook till they're quite right. And we get exactly the shape of the data that we want to get back. And then once we have a good query that we're really happy with, then we turn that into an artifact like this, right? And then we just use that artifact to go hunting everywhere. And, and then we come back with the data and we can post-process it. So we got up to here in this exercise. So what I would like to do now is continue on with the hunting piece. So because we only have one client, hunting is not very exciting, right? Because there's just one client. So I wanted to make more clients. So to give you guys an idea of what it feels like to hunt on a large number of endpoints. So what we've got a little bit of a trick that we use. So we use it in Velociraptor as a way of load testing the Velociraptor. And so we can spin up lots of clients. So this is called a pool client. A pool client is basically, it's just another mode that Velociraptor can work with. And it creates a whole bunch of clients that sort of, they appear to the server as if they are different clients, but they're all, obviously they're all the same. They're just kind of like running lots of clients, in different threads. So they're just, it's just a way of increasing the sort of load on the server. It's very easy to spin up lots of clients. So that's what we're going to do now is we're just going to spin up 50. I mean, 50 is a very small number, right? But for the sake of, expediency, we're going to do that, just 50 of them, right? So let's go in here in a downloads directory. Now, remember that when we started our server, we told it to use mydir as the directory where it should store all of its files. And we are running the Velociraptor GUI setup, right? So if I have a look at this directory, then I can see that these are the config files that it generates for the server and the client. And that's what we're going to use to start up the pool client, right? So the pool client is going to be basically just another client that will just talk to the same server. So remember that the GUI runs the server and the client together, right? So let's start it off. So this is our Velociraptor binary, again, same binary to do everything the same. We're going to give it the configuration of the client, right? And instead of running a regular client, we're going to start a pool client. And we're going to give it number 50. We're going to say 50 hosts. So start up 50 new clients, right? So when I run this, spelled it wrong, config, right? So when I run this, you see it's generating a whole bunch of keys. So it's basically creating these new clients, right? So each of them will be separate. And because they're separate, they'll have different client IDs. So they'll appear to the server as completely different clients. So let's verify that. So if we go over here and look at our dashboard. So this is our dashboard here. You can see that well, CPU load is increasing and they're all enrolling. Show all. These are all the different clients that just kind of appeared, right? And they just appeared. They're kind of the same thing, right? Because they're all the same client, but they have different host names. See, it's just a number, but they behave like separate clients. We can talk to each one separately. We can do a hunt or whatever, right? So this is just for demonstration purposes. In reality, you'll have different clients, and you can see the number, jump up here in the, in the currently connected clients. We're up, should be up at about 50 because we're running about 50. So So let's go to the hunt manager here. And with the hunt manager, then we are able to actually hunt. So again, a hunt is just a way of collecting the same artifact from lots of machines at the same time. Right? So we're just going to click this hunt. We're going to add a hunt. We give it a description. So our description is going to be like get log enabled status, for example. Now a hunt can be can be active for a time. So that means that if new clients appear in that time, they will be assigned to this hunt. And then we can match by label, we can include and exclude and this sort of thing. But for this exercise, we'll just do the basics, right? We'll just run it everywhere. And then we select the artifact. Okay, and we're going to use that custom artifact that we wrote, right? So custom Windows logs enabled. We didn't really have any parameters here, so there's nothing really much to configure. And look, basically that's it. You just launch it. Now, when we start the hunt in this way, then it starts off in the paused state, right? Because we want people to sort of think about it, because we're just about to hit the entire fleet with this collection, right? So we need to know what's going on. We need to be confident. So we're going to push the play button to start it, start the hunt. And what we'll see is that pretty much immediately, that number will start going up, right? We will start to schedule all of these clients. And then these clients will basically, do the thing. And remember that it only took like 0.6 seconds to do this registry lookup, right? It's very quick, right? So it's going to basically, they're all going to come back pretty much instantly. So the one thing that you have to notice that's actually different from GER and many other hunting tools is because Velociraptor is always connected. As soon as you run this hunt, immediately all the endpoints are going to do it, right? So it's very quick in that way, and you don't have to wait for it to poll. There's no polling going on. It's always connected, so it's much faster. So that's cool, right? So basically, what we are seeing here, if we click on the clients tab, then we can see each client and how many rows it came back with. This is like overviews of the statistics. But in this case, they're all the same because it's the same actual client, but they just appear to be different to the system, but they're really the same. If we click on the notebook, then we can do post-processing here. So there's another notebook. This notebook is attached to the hunt. So using that, we can post-process that hunt. So, okay, let's take a look here at what we wanted to do. Okay, so hunting for baseline. What is normal? So we don't know necessarily what's normal. So in this example, we're collecting all of the results. Now, if we have a look at, now is it enabled or disabled? So it's disabled now, right? So in this case, you can see that it's disabled. So what we're going to do is we're going to enable it, right? And then what we're going to do is we're going to start up one extra client, right? So before we had 50 of these pool clients, but now we're going to start up one extra. So this new client is going to have a different setting for this log, right? So we're going to start off, and it just creates a new client and starts off. And then as soon as it does that, you'll see that client will pick the hunt up and do the hunt, right? So we go up to 52 clients. So now we've set up a situation where it's simulated, right? But basically most of the clients have that log actually disabled, and then one client has it enabled. So that way we can see what's different. So let's do some post-processing, and we can figure out what's normal, what's unusual about this network. If most of the machines have the log set to enabled, and one of them has it disabled, that's unusual, right? We want to know. So you can do this thing called stacking. The idea is that you count how many times each log is enabled, right? So in this case, so you can see which ones are unusual. So let's add a count. So this is a count. This is how we count, and then we'll do a group by. And when you do a group by, you're grouping together all of the logs with the correct combinations that you want. So in this case, we're going to group by log name enabled, right? So this one basically groups by the combination of this column and this column. So all the unique columns, all the unique rows from all the machines, right, that have this and this together, they will be put in one group, and then we're going to count them. We're going to count that group, right? So that's what the group by does, right? It groups by, it creates groups based on the same values of these two parameters. So for example, if this log, see how it says enabled 0. So this row will go into this group. But if there was another row later on that had this log as enabled 1, then it will go into a different group because we're grouping by both columns, right? Not just one. So if we do that, then count, and then that will tell us which ones are more common and which ones are less common. So so this is called stacking, this kind of analysis. Sorry. All right, so it's going to go through and build those groups, and then it's going to count them. And remember that this result came from the hunt, so it's all of the results, right? So you can see that most of them will have 52. Most of them are 52, right? Now you can sort of chase it, or we can also order. I mean, you can see that's the odd one out, right? But you can also order by count. Okay, so that just sorts it. So so it's a little bit easier to see. The count is going to be up the top. This is called stacking. So you can see that immediately that first group that has this log with enabled equals 1, there's only one of them, right? And then this log with enabled equals 0, there's 51 of them. So clearly it sticks out, right? If it sticks out, then that's unusual. So this is the type of hunting that we call baselining. So you do a baseline, and then you do stacking, and that tells you what's unusual, what's not usual to the baseline. That's a really good technique for picking up anomalies, right? Cool. So we're able to pick up the anomalies here, and we can tell immediately that this one is enabled or disabled. So when we do a hunt like this, we can see, like, if an attacker went to a machine, they disable that log that's normally enabled on all the other machines. That's very suspicious, very unusual. Why are they doing that? Very strange. So that can be already alerted. So let's go back to our slides and see what we've done. So we added, we post-processed the hunt result. So we can either do it in this notebook or in the hunt notebook. Either one's fine. So we went into a notebook. We did the stacking. We grouped by to split all of the rows into unique rows. Then we used the count to count all the items. Then we did an order by so that we could see which counts are smaller and which counts are bigger, right? And this is kind of what we're getting, right? So this is the sort of stacking, right? So we can see one's out, one is unusual. Yeah, so we immediately see the odd one out. All right, cool. So the next thing, so this is good for when you want to go back after the fact and figure out what is going on, like what happened, right? This is the forensic part. But in terms of DFIR, a lot of the time, what we want to know is, we want to know immediately when this happens, right? We want to know what happens in the future. When someone in the future changes that, we want to know about it immediately, because we don't want to go back and do the post incident, right? We need to turn it from an incident response to a detection. And this is the point of this today's workshop. And I called it, digging deeper as a more advanced kind of workshop, because we're turning into from the standard forensic point into a detection. So we're going to go into more of a detection. Okay, so what we've got here. So what's the time? So we are okay. So it's 12 noon, and we have So we have 2 more hours, right? So let's do maybe a few minutes break, like till 12:05, and then we'll resume after that at 12:05. So let me know if you have any questions. Are you guys following along? Are you finding it, useful, interesting? Cool. Great. All right. So where were we? Okay, cool. All right. So so the point is that what we want to do is we want to create a detection query. And this is where it's quite different from GRR. GRR is more of a forensic kind of tool where you go back after the fact. But because we have a query language at our disposal, then we can actually turn it into a detection query. So this is where it's we need to kind of explain a little bit about how Vql works in a little bit more detail. And the cool thing about Vql is that unlike a normal like SQL, it is asynchronous. And what does that mean? So have you ever used MySQL or any other SQL database, SQLite or whatever, in the past? You would have seen that you would have seen this kind of experience, right? So when you are writing your query in the console, Usually you run the query, and if you happen to have a very large database or your query is quite intensive and takes a long time, then what will happen is it will basically kind of like block for a long time, just waiting for this query to come back, and then and then it will just come back with all the rows like all at once at the end, right? And that's typically how SQL works. It just kind of like collects the result set and then it ships it across when the query is finished. Now, VQL doesn't really work like that. What VQL does is it streams the results as soon as they're available. So, for example, before when we did our big glob with wildcard, then it would search the file system or registry for what we wanted. And then as soon as it found a hit, it returns that back into the query and continues to go ahead and look for things. So it's asynchronous. It doesn't need to wait till the end to actually do to give results. It gives partial results as it goes along. So what does that mean? How do we use that asynchronous property? So imagine if you had a plugin. Again, a plugin is a bit of code that runs and returns rows. So if you have a plugin that just ran forever, like let's say that it just ran forever, never stopped. Well, then obviously the query will run forever, right? Because it's always waiting for data. It's waiting for this plugin. But let's say that this plugin is returning a result set occasionally, right? So sometimes it returns a row. Because VQL is asynchronous, that row will be returned as a partial result set. And then the plugin will go back to doing whatever it was doing, right? So it just takes a very long time. But as the results are available, that row is released. So then the next logical step is to say, well, what if we write a plugin that returns a row whenever some event happens? So something happens and then a row is returned. And that is called an event plugin. So the plugin actually, it waits for an event to happen, and then it returns a row when event happens, and then it goes back to waiting. So a row is going to be processed by the query every time something happens, every time an event happens. This is called an event query. Now, the important thing is the event queries, they don't complete, right? They just keep running forever. They never really stop, right? And they're just returning partial results until they're canceled. So let's have a look at how that actually looks like in a picture. I just wanted to show that, just to explain again how that works. So here we have a plugin, right? And again, a plugin is just a piece of code that returns rows, and some event happens somewhere, right? Let's not worry about what the event could be. It could be anything, but in time, an event like this is time going down here, right? And an event will come out and a row will come out and another row will come out, another row will come out at different times. And then it goes into the rest of the query, and it could be filtered, there could be all kinds of stuff happening to these rows. It goes into the query. And then the query is going to basically batch the results a little bit, because you don't want to send like every row back, right? So you want to batch it a little bit. So it batches it into, let's say, parcels, right? These partial result sets. And then each of these result parcel is sent back to the server, right? So it's streamed back in like chunks. That's what it looks like, right? So, we have some parameters that control like how to batch, these rows. So it doesn't take too long. And then it batches the rows and sends them back, right? So this is kind of how this works. But just to give you guys a feel to what it actually feels like, let me just jump into so we're just going here. Let's create another VQL in the notebook. We'll create another Vql cell. Let's push it up to the top. Then we can write some VQL. So the first example of an event plugin is something called a clock. So we're going to go select star from clock. So clock is a plugin, right? You can see here it's a plugin. So let's just call it how it is, and then see what it feels like to call an event plugin. So let's run it. So when I run it, you'll see that what happens is that it looks like it's working really hard. Like it looks like it's just sitting there waiting for results to come back. But some results are coming back, right? So we have some results coming back, but then, it's still working, right? As I'm waiting, it's just going to keep working. And I can stop it at any time. If I didn't stop it, it would just keep going forever, right? But, well, actually, it times out after a while. But basically, what happens is that this clock plugin, so clock, is the way it works is that every second, it returns a row into the query. And so that row ends up, in this table every second, right? So it's just clocking, right? It just waits and it just sends a row and a row. In fact, the row, it has all kinds of, this is the string time. It has a time in it, right? It's the UTC time, the local time, UTC time, all these things, right? So, yeah, so that's basically how an event query works. It just sits there waiting for events, and then it sends back rows. And then the rows are actually being streamed and written to the table as they happen, right? So they get appended. So that's the now when those event queries are running on the client, they're being streamed into the server, and then we can capture those events, right? So that is really what it's about. So we can turn that into a monitoring architecture. So what we do is we basically take those event queries, we put them on the client, right? So then the client runs them all the time. And then as those results are coming back, remember, partial results are coming back all the time but the query never finishes. It's always running. So then we send back those partial results back to the server, and that's how we stream those events, right? Then we write them to the file store, and we can look at them and stuff like that, right? So that's kind of in principle how it works. Here's a diagram to explain it, maybe a little bit better. So over here, this is the client, right? So here's the client, and we have a whole bunch of event queries that we can tell the client to run. So then they just run, and they will return a row whenever something happens, right here. But they're always running. And then partial result sets are being sent from there. Now, we also have a client buffer file. So if the client is offline, then it just gets written to a file, right? Then when the client comes back online, then all of these events, they get synchronized back into the server, and then we write them on the file store, right? So the idea here is, the important part here is that these event queries are running completely independently of the server. The client knows what it's doing, and it's running those queries by itself, right? And even the client can be offline, doesn't matter, right? Those queries, the results from those queries, they get queued up in the locally on the client until the client comes back online, and then syncs it up to the server, and we're still getting those events, right? So those event queries, they can actually alert on or collect events to do with anything, even if it's offline, right? And then we'll know about them later, right? So that becomes kind of like autonomous. They're sort of autonomous, these queries. They work by themselves. And I'm very excited about this aspect. Actually, I quite like it. And the reason that I'm very excited about it is because I think that it actually disrupts the way that the current industry works, with the way that the architecture works in SIEM and DFIR in general. This is kind of my diagram to show you how the industry works now, right? Like the current state of things. And this is how most of the EDRs sort of work now. So that they have some sensors on the endpoint here that collect events. And these sensors can be anything from Sysmon, collecting event logs, or or win beats, file beats, all kinds of stuff, right? And essentially, all of these things, they write logs to the endpoint, and then those logs are getting forwarded to a SIEM, some kind of backend, right? And now in this SIEM, there's all kinds of detection processes that are happening on these logs, and all kinds of stuff is happening. And you might have an alert raised by putting together different, and it doesn't just come from the endpoint, right? Like you can have network events or other things, but a lot of these detections come from the endpoint. And then you can detect there's some rules in the SIEM, right? That basically say, oh, this event means something bad or whatever. And then you have an escalation coming up from the SIEM. And then you have the SIEM operator or analyst that looks at those events and then says, oh, I need to figure out if they're false positives or false negatives. So then usually the escalation, then the SIEM operator has some kind of a playbook, and they say, oh, if I get this kind of escalation, I need to determine if it's a false positive. So I've got to go and collect more data, let's say. So they go back, and usually the EDRs have API that people can use to collect more data or, do more investigation, or it could just be Velociraptor here as well. But then they go back to the response and then they collect more data. So it goes back here to the endpoint and collects more data. And then it goes back through the SIEM and they get data and they look at it to determine if it's a false positive or whatever, right? So this is called an OODA loop, right? Because it's it's basically an orientation action loop, right? So it takes a long time in the industry to do this. By the time the escalation comes through, and then the SIEM operator constantly has to go and seek out new data and get new data. And so this takes a long time. But with the Velociraptor event query, what happens is this whole OODA loop gets shorter. Why? Because you already have the ability to write an event query. The event query runs by itself. It doesn't need to go back to the server, doesn't need to get escalation. It doesn't need to get, the SIEM operator doesn't need to tell it what to do. It already knows what to do. And so it knows how to enrich that event automatically. So we can have all of the detection, instead of the detection rules being here and then going back through this way, the detection rules can be moved straight into the event, the client, the endpoint, right? And so the endpoint can detect on its own whether something is unusual or bad or malicious. And we can already add enrichment rules to this so they can go ahead and enrich that data. This is very exciting because by the time the SIEM operator gets that data, it's already got all the extra stuff, the extra detection, the extra enrichment, all that extra stuff is already, in there. So they are in a much better shape to determine whether it's a false positive or not or whatever, right? So this is the point of Velociraptor. So let's turn this question around and continue on with our exploration of let's detect when the log is disabled, right? So it'd be really awesome to know when the log was disabled. So we want to do an event query to figure that out. Now you can do a number of ways. Let's go back here. One way is to use sysmon to monitor for registry keys changing, and that's possible. But what we want to do is you can actually do it we're gonna look at this, how to do that later. But for this, we're gonna do something really, really dumb, right? Pretty straightforward, pretty simple, right? In the first iteration. So what if, remember that it only took us 0.6 seconds to figure out which logs were, enabled or disabled. Oh, sorry, so there's a question. Velociraptor response that you describe is kind of similar with some EDR. I don't understand what Velociraptor does more than EDR is. Oh, well, that's an excellent question. So the EDRs, what they do is they have a detection, right? So, so they send back the logs or they collect the data. The EDRs typically, what they do is they're just kind of sensors. So they have, they have the sensors, right? So this is, they collect the data and they forward it to the SIEM, right? but they don't have the ability to enrich the data. Like, so for example, like let's give you a real example. Like, let's say that you have an event, a sysmon event log that says, oh, a driver was inserted into the system, right? So is that driver good or bad? No one knows, right? Who knows? So what normally will happen is you'll get an event that comes back to the scene that says driver is inserted into the system. So you have an escalation, right? And then you might have this, you might have a remediation, right? But then the operator has to go back and say, okay, well, give me more information about it. What's the hash? What's the, was it signed by, what was it signed by? Now, some of this stuff is already, provided, right, by the EDR because it's a common thing. But a lot of this stuff, a lot of the newer stuff is not, right? So you don't necessarily have that level of enrichment that you could have with Velociraptor. Because Velociraptor has a query, you can actually write any kind of enrichment that you want, like even grab the file, like copy the file and upload it, or, so you can basically, it's much more flexible. A lot of like something like a driver signature that's inserted, that's probably common enough for the EDR to already have that. But something like, modification times or prefetch or parsing or anything that's a little bit unusual, you can't really do that in an EDR because it doesn't have that flexibility in the query language. You'll see as we go along with these examples, you'll see how that plays out, and think about whether an EDR can do that same thing. I don't think the EDR is quite as flexible because it relies on this kind of loop to go back from the operator to decide to do the remediation, right? It doesn't necessarily, remediation is a whole other thing. You don't want to necessarily automate the remediation part because it's kind of risky, but the enrichment part is definitely something we need to automate a lot more and get more data. But let's go through this example. Yeah, it'd be good. Absolutely, get some feedback. It would be great. So let's see. Have a look at the Diff plugin and see what. So that's a pretty simple example of an event query, right? Because all the Diff plugin does is it looks at the difference between running the same query in two different times periodically, and that allows us to detect changes, right? So this is pretty simple approach, and it works, much the same as I've got here an example. So I'm just going to copy and paste it so it's less typing. So just to save time. So let's go back to this example here. And what we're going to do is we're going to run this example here. So it's the same thing as what we had before, right? There's the query, and you would recognize that this here is the query that we had, before, basically, right? So we have the D name, the log, the data. That's more or less the same. But what we're going to do is we're actually going to run this inside of another plugin. And this is an example of Vql being able to run a subquery inside of an argument to another plugin, right? So, and so the Diff plugin, what it does is it takes one parameter called query, and then it runs this query over and over, right? And then it has to decide whether any of these rows have changed from, each time, right? So what we're going to do is we're going to create a key, which is a string, and then that key basically essentially it's combining the key, the path, right? So which also contains the log source as well, and the value, whether it's 0 or 1. And so it runs the query, and each time it's the same, it doesn't do anything, right? But then if it changes, then it will return rows that will indicate that was a change, right? So it basically does a change. So let's see how that works. So we're going to run this, and you'll see that basically nothing will happen. It's basically running through, and it's it's nothing. No rows are released, right? No data is available, right? But it's basically running this query over and over. Now, if we go over here and we change the state of this one, so we'll disable it, right? So what happens is that now, when it does the query again, there would be a change, and when there's a change, then it will return the difference between the rows, right? So it detects a change. So it's telling us that this registry key is changed. Now it's not super accurate, right? Because it doesn't detect very quick changes, right? Because it's like a polling type system, right? But in this case, it's probably fine, because if someone turns the logs off, they'll probably turn it off for a while, and so you might be able, you don't have to query quite so often. I mean, in this case, we're doing it every few seconds, but we can actually do it every 10 minutes or whatever, right? So we can actually find it. So we can see that much less frequently. So this is an example of the Diff plugin. And it's the most simple one. You can see that this is the key, and it basically shows us when the key is changed, right? So the key is changed from a 0 to a 1, so it changes. So it's saying this row was added, this row was removed. So using this, we can detect when we enable or disable this log, right? So that is an event query. So the query itself is just VQL, right? It just runs as normal. But now what we're going to do is we're going to convert it into an event artifact that we can actually use to monitor for changes on the system. So like we did before, what we're going to do is we're going to go over to the this one, artifact, create a new artifact. We're going to create a new artifact again. And this one is going to be Windows. Oops, sorry. What happened here? Okay. Windows dot logs dot enabled events. I don't know, we'll just call it events. And we can describe it, whatever. Oh, well, I mean, yeah, we'll leave that for now. And this time, instead of being a client artifact, because we're not really just, it's not just like a single collection where we collect it and finish, right? It's a client event artifact. So we're collecting events on the client, right? So we're going to change the type. It's going to be a client event. So this one. And then what we're going to do is we're going to copy. So the same kind of thing. We're going to copy this query, okay, put it here, paste, and we're just going to have to tab it over a bit because it's YAML. So off we go. So it's right. And yeah, and we're going to just, it's going to be on Windows. So we'll do a precondition like this. And, well, we don't really need to worry about the parameters, we'll just do that, right? So that's a very simple, so that is again the same process that we did before, but we're just creating an event query. So now when we save it, so we created this new one, that's an event, client event, right? So, and it's doing this diff thing where it checks every 5 seconds. I mean, in reality, you probably check less frequently than that, but for this example, we'll use that. So we've just created that query, right? So we created that artifact. So we know about it, but now we have to actually deploy it. So we have to tell the endpoint, use that artifact and tell me when something happens. Tell me when this changed, okay? When this registry key changed. So I'm going to go over here and you can see that I have this thing called client events. So this is where I manage the client events. They're a little bit different, right? So the client events are basically those queries. Remember that we had it in the picture here. When I showed you the diagram, you see how I have, these are the event queries that are running on the client, right? So somewhere, in the UI, I have to be able to kind of tell the clients what events to run, right? So what artifacts to collect there. So I click on this, editing button, and that allows me to edit the policy. Now, client events usually are targeted by label groups. So you remember how I mentioned before, you can label machines, and that allows you to put them in groups. And then you can use those labels to target hunts, but you can also use them to target these event monitoring. They're just kind of groups. So you can say like, like all the servers monitor for that, all the laptops monitor for that, like these kind of things, right? So, but we can say all, which all means they're all going to be targeted. So all the labels, remember I added the mic label before, but let's go all. Now, by default, we always collect these client stats. Remember I showed you those, the footprints that we collect from the client. So it is just an event artifact like all the other ones. But now we're going to add another one. So this is the one that we wrote, just now, right? So we're just going to launch it, right? So what will happen is as soon as I launch it, is that those clients, all the clients will receive a new set of queries here, and they'll start to run them. Now over here, as you can see, let me just go back here. I can now select this artifact here, right? So if I select it, I don't have any results yet, but on this side, I can change between the data that came back or the logs. So the logs are telling me the query started. So now I know on that. So this is the client we're talking about here, right? Because we're still inside talking about this client here. So this client is now running this query, right? So it's working. So it's waiting for events. So nothing really is happening, but it's waiting. So now this is it just runs by itself, right? So if I go over here and I change this, so I enable it or disable it, then what will happen is that the query will pick it up and then send the results back. And remember that these results are coming back and they'll get buffered here for a time. And by default, it's a couple of minutes because we don't want to be, accessing the network too much. But so we're just kind of like buffering them up and then just sending them every couple of minutes. So you'll see after a little while, we'll see, yeah. So after a little while, we should be able to see that that data coming through that tells us this log changed, usually within a few minutes, right? So that's how we convert. Let me go back to yep. So that's how we convert from our query into an artifact. So we turn it into an artifact, then we collect it, and then we assign it to all the clients in this group, in this case, the all group, and it's added to that, and then after a while we'll get the results. Hopefully, you should get some data by now. Yep. So the results are back. So that data is streamed every couple of minutes to the server, and so now we've seen that someone has changed this value, right? So we can see that it's gone from 1. So 1 was added, so it's being enabled, and 0 is removed, right? So it's this, so we can interpret that, but anyway, that's the idea, right? So someone enabled the log, but you can tell when the state has changed, right? So you can refine this and figure that out, right? So you can see that now this is a detection that that we can run in an event query. Now, of course, in this is a very simple example, and a lot of EDRs, in the case of an EDR, you may be able to get something similar by simply, let's say, if you have an EDR that has sysmon, I mean, you can't really monitor every registry key, but maybe you can have a sysmon rule that monitors those particular keys, and then trigger on them, so there could be some overlap, right? But because of these keys, but Velociraptor can do quite a lot more with it because it's actually sitting there monitoring on the endpoint, and then it can do things like collect data, or in fact, it can actually also do the remediation. Like if someone turns it off, it can turn it back on, as well as alerting. So these kind of things. But anyway, this is just an example of how that works. Now I have an example. The next exercise here is more about forensics, and because we're doing some Ntfs type thing. So let's, yeah, I think we'll go through that. I'm just worried that we might run out of time towards the end, but yeah, we'll see how we go. Maybe we'll skip that a little bit. Is there any questions so far about these remediations, about the events? We're going to go back to events later on to do more monitoring. But that was just the first example. Okay, if there's no questions, let's dive into the next exercise, the next section. And this exercise is about a vulnerability in the Dell driver. So it's been probably like a month, I think, since there was this vulnerability announced in this Dell driver. So it turns out that this is a Dell driver. So many questions to ask them right now. Okay. So this is a Dell driver. And it turns out that this driver is very old and it's written pretty poorly. So it has a lot of vulnerabilities in it. And so for those of you who don't know, drivers on Windows generally need to be signed. And generally, you can't just create a driver yourself, right? You have to sign it. And once you sign it, then you can insert it into the kernel. But if you can use a driver that's very vulnerable, so it's written pretty badly, but is already signed, then you can still insert it into the kernel, and then you can exploit it, and then you can get into ring 0, right? So you can basically get into kernel level access, and then you can load your kernel rootkit, and off you go, right? So typically vulnerable drivers like this are typically used as part of rootkits, even if you don't have a Dell driver, or if it's not even a Dell system, the attacker can bring that with them as well. But let's just say that we start off and assume that we have this Dell driver. So we're just going to download it from, this is the actual driver, right? The vulnerable one. And we'll just do a keep. And what we're going to do is we're going to copy it into this location here, because this is kind of like where it's supposed to go. So this is the dbutil, and let's see, it's going to be /appdata local temp. So we're just going to put it there. Yep. And so imagine that we had a there was an advisory. And this actually happened like I think a few months ago. No, not even a few months ago. An advisory came out. There's May 4th, right? So Dell driver, very vulnerable, super bad, widely installed, and it's a trusted part, so it can be loaded and can be used to provide kernel level access. Very bad, right? So the question is, whenever this kind of vulnerability announcement is made, most people want to know, am I vulnerable? Do I have this driver on my system? Okay, so most people would go to the Dell website and have a read of this, an announcement, right? So there is this vulnerability, and the impact is high, so it's actually quite a dangerous one, right? Insufficient access control, blah blah blah, right? So how do we remediate it? So if you read this document and you go down, and then it explains how you remediate this. How do you fix this? Well, the first thing you do is you check the following locations for this file. C user appdata local temp. This is where we put it, right? Or C Windows temp, right? And then you have to hold the Shift key and delete it, right? So this is all right when you have like 2 machines, right? You could probably go and do that manually. But if you have 10,000 machines, how the hell do you do this, right? It's just not scalable. So you have to do something a little bit more, more intricate than that. So this is another example of how we can use Velociraptor to quickly respond to these kind of things. So let's go and hunt everywhere and see, you know, which machines have this thing. So hunting, again, is collecting the same artifact from many endpoints. That's called hunting. So we've already seen an example of that. Hunting is just a container. It's just grouping together individual collections. So you can just download them all at the same time, but they're just the same as collecting it individually from each machine. And then we talked about that before, that the hunts are active until they expire. And that when the endpoint is not currently online, it will receive the hunt when it checks in next time, right? Because we've seen before that endpoints come online and offline all the time, right? So this allows us to schedule a hunt, and then in the time zone when the endpoint comes back online, then it will do it as well. All right. So, oh, by the way, these screenshots here, they use the dark mode. So we have a dark mode. If you guys are into that, you just click on this thing and you just select dark mode. So I think that dark mode is also kind of pretty, whatever you want, right? This is all the newest. It also has more colors, so it's more colorful. So I can leave it as the dark mode as well. So the first thing that we're going to do is we're going to create a hunt to see whether any of our machines have this file, right? So this is kind of what we're looking for according to the Dell advisory. So actually what happens is that this is part of a BIOS upgrade kind of tool. This driver is used to provide access to the BIOS. And when you're doing a BIOS update, it drops this dbutil into the temp folder. And that's where it leaves it there, right? So that's where it ends up being. So if you want to know if you have that driver, then you can simply look in this directory, right? It's not a very good check anyway, but okay, whatever. We're going to check for that. So what we're going to do is we're going to look for an artifact called a file finder. File finder is a way to find files, right? So all you have to do is an artifact where you give it basically parameters, right? So you give it this glob wildcard. So let's go over here, create another hunt, and look for dbutil. Okay, so we're going to create a file finder, search for finder. So this is our file finder, and it's just a general purpose artifact that just it ends up using glob and all the normal VQL, but you don't have to know about that. It just gives you a whole bunch of controls to be able to figure out, you know, where things are. And according to the advisory, it's going to be in the users directory. It's going to be app, the app. This is where we put it, right? So the app data local temp, right? So we can copy that. Okay. So it's going to be app data local temp dbutil 23.6, right? So this is basically going to search for it using this wildcard, and we're going to see whether we could just calculate the hash as well, so we'll know if it's the right version or whatever. And that's basically it, right? So we go for it again, create the hunt, start it, run it, right? So again, we're going to see these. We have 50 machines, right? So the 50 machines will start working. And because they're all the same, really, they will basically all find the file because they just copied it there, right? So this will tell me, oh yeah, these all of these machines have this dbutil file in it, right? So that's cool. So I've got detection, and normally when I'll do this, if I'll do this on the whole fleet, then I'll be able to see which machines are vulnerable. So this is what we do. We can run the hunt. The hunt expires a certain time. So for the next week. See, if I look at the hunt, it expires in 6 days, 23 hours, right? So for the next week, any machine that will come and connect to this server will do the hunt and collect and then find this dbutil file there, right? So So we have that, right? So, and then, we do this, and these are the parameters to the hunt that I've just provided, calculate the hash and so on. So that's great. And then we can see the results. I've got 50 machines. This is just one, but they're all the same. They're going to find it, right? And then I have a hash, and I can use the hash to, put it in VirusTotal to see, whether it's a reasonable hash or not, right? So I know that. Cool. So that tells us whether we're vulnerable. Now, it's possible that that it could have been part. This is a vulnerable driver, right? So maybe attackers brought it as part of another exploit attempt, right? So it doesn't always have to be in that directory. For example, it might have been dropped off in another part of the disk and inserted into the kernel from there. And if that was the case, just for exploitation and local privilege escalation, right? So what we want to do now is we want to search for that file in a different location that's not necessarily in the app data local directory, right? So what we're going to do is we're going to do an Ntfs scan. Now, as you know, Ntfs is the standard file system on Windows. And I'm not going to talk too much about Ntfs because you guys probably already know a lot about it. So we're just going to talk about Ntfs. So we have a master file table. It's just a table that has all the files in the table, right? They're called MFT entries. They're all in the MFT entries. They contain attributes. You can have long names and short names and data and so on, right? So this is just Ntfs. But the thing to take out of this is that all the files on the file system are found in the not the metadata of the files, not the actual content, is found in the master file table. So it means that we can actually scan the master file table for metadata, for all the metadata about the file system, right? So like timestamps and other things. This is a picture of what it looks like. This is the MFT, and we just have these MFT records go along. And then the actual data is stored somewhere else on the disk, but the metadata is all in the MFT. So it's a nice, easy way for us to quickly look at all of the file system in one hit. So we can just scan the MFT straight away and get all the information. So now you know that, in a lot of the forensic analysis that you guys do, it's very common to collect the MFT off the machine and then to analyze it offline, like using another tool, like analyze mft.py or whatever, right? And that's okay, but it doesn't really scale, right? Because if you're trying to, like if we had 10,000 machines and you're trying to, copy the MFT of 10,000 machines, it's like 400 megs a machine, right? So that's quite a lot of data. So you can't really do that. So what Velociraptor allows you to do is to scan the MFT on the endpoint itself. So when you do that, you're only returning back those exact files or those exact rows that you actually are interested in. You don't care about most of the MFT. You only care about those MFT entries that you want to know about. So here's the example. So what we're going to do is we're going to create an MFT we're going to do a hunt. It's going to be search MFT for dbutil, right? So we're going to search it. We're going to select the hunt is going to be an MFT, right? And this is the straight out MFT search. And what this artifact does is it just goes through all the MFT entries and just prints them all out, right? And then we're allowed to filter them by all these criteria. So let's have a look at some of the criteria that we can use. So we can use a path regex or file regex. So dbutil, that's going to be our file, right? So all the files that contain dbutil, we're going to look for, right? And we can do like dates, we can restrict it by dates and so on, right? So we're going to do this, and it is basically going to look through the entire MFT. right? So let's launch that, and it's going to take maybe a couple of minutes to scan the MFT, and you can see that it will. Here, it's starting to get scheduled. So we got like they're all scheduled, but they'll take a couple of minutes to do it, right? Each of the clients, right? So we're going to schedule it on 50 clients, but it's going to take maybe a couple of minutes to do it. So we'll just leave it to do that. But I just wanted to point out to you that normally an MFT, when you scan, like print out all of the MFT entries, normally you're talking about something like 400,000 rows per client, right? Per MFT, because the MFT contains information about every file on the disk. But what we're doing here is, because we're filtering down, only look at the files that match the DBUTLs, then we don't really expect too many rows to come back, right? We're only expecting relevant rows to come back. See, we're starting to get results. So let's take a look. Okay, we're getting so here we're getting 26 rows coming back, right? So let's recalculate that. So we can see that our DBUTL is not very still not very tight as well, right? So we probably should do a dbutil.sys. See, there's some false positives, right? But there's not very many rows that come back. So when we do this on 10,000 machines, what we're going to get back is, maybe 10, 20,000 rows, not that many, right? Very few. And as opposed to 400,000 or 500,000 rows per machine, right? Because we're doing the filtering on the endpoint. It's very, very targeted. This goes back to this whole surgical thing we talked about before, right? So this should only really come back with, the .sys files, right? So yeah, so this is what it's showing. We can do a big hunt, several thousand machines, and essentially come back with only those files that are called dbutil, right? So that allows us to hunt across the disk. Cool. So the next thing I want to talk about is like, okay, did the files exist in the past? So this shows us whether the files are there at any time. But what happened if the file was deleted? So they had a file, then they deleted it, right? How do we know if the file was deleted? Now, sometimes when we do an MFT scan, we can see unallocated files. But for those of you that have done a lot of Ntfs type analysis, it happens, but it's not that common, because Ntfs is actually pretty aggressive at reusing MFT entries. So you can see sometimes like unallocated entries, but a lot of the time, not really, right? So for example, if I go over here, so let me try that. So I have this file here, dbutil.sys, right? So I'm going to delete it. Yeah, so delete it from here. And while I'm at it, I'm also going to delete it from the app data. Okay, so now I don't have any of those files on the system. So if I do an MFT scan, I might still see it, but probably depending on how much activity happens between now and then, not often, right? A lot of the time that will disappear. So I won't have any evidence that this existed on the system, except if I use something like the USN journal. So it does. So the USN journal is actually pretty cool, because it is a journal that just keeps a track of all the file system changes that happen, right? So every time there's a file system change, Windows writes another entry in the journal. So the USN journal gets rotated, right, after 30 megs or so. So it's not that big. And depending on the system, how active the system is, sometimes it will last for about a day. Sometimes it will last for a week. It really depends. But we can actually get this information from the USN journal. So so let's look at that example again, right? What we're going to do is we're going to basically scan the USN journal, but again, we're not downloading it. We're scanning it on the endpoint itself, because we only really care about files with a specific name. So let's go back and we're going to search for USN, right? So that will give us an example, search for any kind of, so we can carve it as well if we're really desperate, but it's a lot more expensive. So let's just go for just the normal USN scan. So what that does is it essentially parses the USN on the endpoint, and it just kind of like has one row per USN entry. And then what we're going to do is we're going to filter dbutil. So let me just get that right. dbutil _2_3, right? So _2_3. Okay, and we just go for it, right? And what it will do is we will load the USN, scan it, and then tell us any kind of row, any kind of interactions with a file of this name. So even if it's added, written, modified, deleted, any of this stuff will result in a row. So it's going to take a couple of minutes to parse this USN journal. So each of these clients, each of the endpoints, they're doing it, right? So they're parsing in parallel. So we can do it on 2,000 machines, on 10,000 machines. It still takes the same amount of time because it's each one is doing it in parallel, right? So that's that's one of the differences. In a traditional approach, we actually go and collect the USN and then parse it offline using other tools, but that doesn't scale, right? Because if I have 10,000 USN files, then it's linear, right? So I have to scan to parse them and post-process them, and it doesn't scale, right? But it's much faster to do it this way. So here we go. We got some results. So when the results come back, okay, and then we can see essentially these are the USN operations. Now here we have the reason, which tells us why this this is renaming and so on. And then we will see that at some point there will be a delete, maybe in the next page, file override extends, and there will be a delete somewhere, and that would be when the file was deleted. So we'll be able to tell that the file was actually removed. It's renamed and truncated. Just go through there. Here, so there's a file delete, right? Because I just deleted it. So you're able to see, now it's really cool because there's a timestamp here and you're able to see exactly when the file was deleted. That has nothing to do with the MFT entry was reused or anything, right? It doesn't matter because it's in the log and it's in the USN journal. So USN journal, really awesome. You can also carve for USN journal because it rotates out. So if it rotated out, you can carve for it and maybe you're lucky to find some of the old entries as well. So USN journal, pretty awesome. So we did that. We looked at the deleted files, and now we can look at some other properties of the file, right? So anti-forensics. So far we've been hunting for files that have that name, but maybe the attacker just changed the name, right? It's really easy to rename a file, right? So a name is not a very strong indicator. So we can try and look for a hash, which is a much better indicator. But typically, what we could do is we could look for, if you just look for a hash normally, then it's very expensive because you'll have to hash every file on the disk and then see if it compares to your file, right? So that's very expensive, but it doesn't make any sense, right, either to do that, because we know in this case that the dbutil has a particular size, and it's much, much cheaper to check the size of a file than to calculate the hash of a file, right? So what we can actually do is we can write a query that looks at all the MFT files, checks for all the files that have this size, this exact size, right? And only if that size is correct, then we hash it. So that is much faster than hashing every file on this and just matching on hash, right? Because that's just going to be far too slow. So it turns out that this kind of query is extremely quick, because there aren't that many files that have this exact size, right? And so So it turns out that's a much, much faster query. And this is an example of VQL being very efficient in the way that the query is written. It's evaluated left to right. So first we check the size, then we calculate the hash. So this is an example of VQL being very efficient about the way the query is executed. I'm just going to quickly go over this because I want to leave the last session to the last part, which is actually a little bit more interesting. So I'm just going to skip this this thing, but what we're doing here is we're also checking for hashes and signatures, which is also quite interesting. Hunting by hash is weak. I just wanted to say this. All of the people who are hunting by hash, it's pretty weak because you can change a hash by just appending, data, right? So if you append a couple of bytes on the end or change a couple of bytes on the end, then it changes the hash. But because this is a driver, then you have a digital signature in the driver, and the digital signature doesn't change. So digital signatures don't change so that you can change a file and that will change the file hash without changing the digital signature. In this case, an attacker bringing this vulnerable driver along as part of an exploit kit, they're still interested in that signature being correct. The digital signature has to be right so they can load it. But they want to perhaps avoid detection by hash, file hash. So they will change that file hash. And we've seen that a lot of the time happens where malware deliberately adds some random bytes to the end in order to defeat that hash detections. What we really need is to use authenticate hashes as indicators, not file hashes. But even VirusTotal doesn't have authenticate hashes. That's kind of a problem. So yeah, so what we can do is we can use authenticate hashes to verify it and these kind of things. This goes back to your question before. For example, like you have this thing, a driver is loaded, and then even Sysmon will calculate the file hash of that driver. Well, that's completely useless. The file hash is useless because you can change the file hash, but it doesn't tell you anything, right? It just tells you it's a unique hash, but you don't know what it is. But if you calculate the authenticate hash, then the authenticate hash cannot be changed. Otherwise, the driver is invalid. So Velociraptor can do that, whereas Sysmon cannot, right? So this is an example where you're doing like above and beyond what is, because otherwise it has to be kind of programmed into Sysmon to do this. Yeah. So I'm just going to quickly go over this. I mean, this exercise goes on for a bit, but I wanted to go to the last part. I wanted to leave, maybe we'll come back to it if we have time. But I wanted to go up to this part, which is the event tracing for Windows. And I wanted to go over that for the next part. So I did want to have maybe like we'll make like a 2 or 3 minute break because we are in the last part of the session right now. So we don't want to run over time. So let's come back in, let's say 2 minutes. So it will be, let's go back. What's the time now? Okay, so 1:04. Let's come back at like 1:08. Let's say it's 3 minutes, and just enough time. And then we can do that last part, which I think is a little bit more interesting. So if you're actually interested in working through that last exercise, you can actually, we did do that before. We have a YouTube channel as well. And I think I did a video on that example, the Dell driver example, and it's on YouTube. So if you search for Velociraptor, DFIR, then this video here is Just pause it. So that's basically going through the same example, and it goes through all of the rest of the exercise. So again, the part that we skipped over here is covered. I just wanted to so you guys can look at that at a later time. I just wanted to go to the last part because this part is new and we don't have a video of that part yet. So. Okay, so we'll resume again at 108, let's say. And if you guys have any questions, let me know. Just ask them away in the chat or. All right, all right. Let's try and get through that last part. Cool. So I wanted to talk a little bit about event tracing for Windows because that's a fairly recent capability in Velociraptor, and it allows us to do a lot of EDR-y things, you know, monitoring and detection type functionality. So it's a little bit different from the kind of traditional forensic-y type work that we're talking about. So we talked about, you know, the Ntfs and the USN journal and the prefetch and all of these usual forensic artifacts. But with ETW, that gives us real-time information about how the state of the system changes. And we've seen before that we had that Diff plugin where we could use that to tell us when things were changing, right? Because we could do a query at one time and we could do the same query at another time, a few seconds later, and then we could take the difference between them. That's a pretty crude way of kind of understanding how the system changes because it's unable to catch very quick changes. Like if someone disabled the log, did the thing, and then re-enabled the log, it's possible that we won't see that because we are going to miss that between each sampling of the system. So ETW allows us to get information about how the system is changing in real time. And that is a pretty critical capability. And it also gives us visibility into a lot of very important processes that are going on inside the system. So ETW is central to Windows. And in fact, that's how event logging works. It works on top of ETW these days. So let's have a look at an example. This is the picture of the architecture of how it works. And what you should take away from this is that the way that ETW works is that Windows is just the broker. It's just a broker between two parties. One party is called a provider, and it provides events. And then the other party is called a consumer that consumes events. And so Windows is just a broker. It has a bunch of providers. The providers are just pieces of code like programs, and they register with Windows to say, hey, I can provide this kind of events, this kind of information. And then over here, you have a consumer, and the consumer says to Windows, hey, I'd like you to please connect me with this provider. And then Windows can connect you, the consumer, with the provider through either through a session. This is called a session, right? So there's a session, and you can use the session to connect between a provider and a consumer. So that's kind of Windows is like the broker between the two. So now it's important to see that there's a difference between the way the data flows and the way that the controller, the control flows. But essentially, the controller just controls where the data is going, right? So the events are actually sent between consumers and providers. So Velociraptor is an event consumer. And so you can actually, in Velociraptor, you can say, I'd like to listen to this event and then listen to it. So the way that it works, you can see all the providers in Windows using this command, logman providers. So we just run that. You can see that Windows will print all the event providers, which are the ETW providers. It's going to take a little while. We'll just leave that to go along. And you can get information about particular providers. So in this case, we're going to look at this DNS client provider. See, so it just shows you all the providers, and the Windows DNS client is one of those providers. Now you'll see that you have a name. That's the name of the provider. And over here, there's a GUID, which is a UUID of the provider. Now, internally in Windows, it doesn't really care about the name that much. It really just cares about the GUID. The GUID is how we register for how the provider registers. So when we want to listen to an event that comes from a provider, then we need to specify this GUID. And so you see each of those providers has a name and a GUID. Now, if you want to, if you just provide to this command the name of the provider, then it's going to give you more information about this provider. So it tells you like keywords. We're going to talk about keywords later, and then you can have a list of processes that are actually providing these events, right? That are participating in this event, and all that means is that essentially, like this one is this particular provider is going to give us events related to DNS lookups, right? So it's a DNS client provider. So these are basically all the programs, all the binaries that have the DNS stub loaded into them, right? So they will provide, these are PIDs, right? They will actually generate events. So when we listen to events here, then we'll be able to see all the DNS queries that are going on in the system, right? So it gives us a really good visibility of what's going on. All right, so the problem is that a lot of this stuff is not really that well documented. And so it's actually quite difficult to understand exactly what is going on. So it is possible to more or less introspect that data through something called manifest files. And it's, as usual for a lot of the Microsoft stuff, it's super complicated. But there are some efforts out there to help document these things. So this is a really good project that I found. Basically, they're calling APIs to enumerate all the information about the different ETW providers, but they're kind of dumping out and collecting all these manifests, which are just XML files. So to give you an example, so here they have these different versions of Windows, but mostly they're the same, but they might change. Let me just make this a little bit bigger. Yeah. So for example, if we're looking for Microsoft Windows DNS clients, so this is, so we just kind of like look here, and here's a DNS client, right? And this is called a manifest, which is kind of describes the provider in kind of more details. And I find that super useful to understand what exactly you can expect from this provider. So you can see this is the GUID, right? Which is, we've seen that before. And then these are the keywords. So this we've seen that before as well. And then over here, there's something called a task, and then we have this thing called events. And these are event IDs, right? And this symbol is basically, it tells you about, what it is. what it's kind of a name, I guess. Some of them are fairly generic, so this still doesn't help, right? It doesn't help all that much, but some of them kind of give you a clue as to what they're supposed to be. And, and some of them don't. So it's not super well documented, but you can usually figure it out somehow. But let's have a look at an example. So let's have a look at how that works. So this is the reference, and we can use that. But let's start off with with DNS. So what are we doing? Okay, so yeah, so this is the bits client, right? So this is the same thing that we did before, right? So we enable the logging, and remember how we turned on and off that event log, right? And remember that when we turned the event log off, then we didn't see any logs, right? But what happens is in Windows, the logs are actually generated by ETW. ETW is really the thing that makes it work. So you can actually still listen to the logs from ETW, and it has nothing to do with the event log system, right? It's like a layer below that. It's like below that. So so this is what I wanted to demonstrate here, is that if you basically so if you take a look at, take a look at the providers, and then one of the providers will be called, this is the bits client, right? So this is the Windows bits client log, right? So you'll see that there's a provider here for the bits client. Windows, there it is. Bits client, right? So this is the provider for the bits client. That UID, that's a provider ID, right? So we talked about that before. You can actually use that and then just receive the events from that provider. So let's go over here, go over to our notebook, just like before. And what we're going to do this time is, let me just make that a bit bigger. Okay, let's delete that. Select star from, we're going to watch the ETW provider. Okay, so the GUID, we push question mark to find out what parameters it takes. So the GUID, then we paste that GUID, right, and then run it. So again, it's an event plugin, so it just sits there waiting for events. We're going to see it coming through, right? So it's going to go through here, and it's going to have no results at the moment. So what we're going to do now is we might start a bits transfer. So here's our bits transfer. We're going to do it like we did before, but now we're going to see those events happening in ETW. They'll come in from ETW, and you see here we have the events. So we have actually quite a lot of different events, and some of them are kind of like they have no data, right? They're pretty useless, and some of them are not that interesting. And this is the this is the event data that's generated by each event, right? So but some of them, you see, they all have different ID here. And what does that mean? It's hard to know, right? You can look at the reference here. So if we go over to this reference in this bits client, this one, right? So let's see. So this ID, for instance, is 83, right? So what does it mean? Let's see. So event ID, 83. It doesn't really help. It just says task 83. I don't know. It doesn't mean anything, right? So a lot of these things don't necessarily mean anything. But if we go up to the end, then we might see something that's a little bit more useful. So see, this one is more useful. That's telling us who's the job owner, the job ID, what did they do, what are they downloading. This is what we want, right? That's the information we want. And we have ID 4, right? So when we go over here to ID 4, what does it mean? Okay. Oh, we still don't know. It just says task 4. This doesn't help, right? We don't know necessarily what it is, but it's pretty obvious from context that this is useful. That's an ID 60. Oh, that's better. So what's ID 60? Stop, right? So this is when it was stopped, right? When the task was stopped. So anyway, you can look at these events and figure out what they mean exactly, right? And like 16403, right? So, oops, 16. It doesn't even list it here. I don't know, right? So, but anyway, you can almost guess what it means, right? From there. Yeah. So now a lot of these are not super useful, but looks like the 60 is quite useful, right? Because it's telling us a lot of information about, when things were downloaded, where it was downloaded from, how many bytes were transferred, these kind of things, right? So we can go through and redo our artifact, right? So we're still listening to all the events, but we are filtering out on system ID equals 60, right? That was the most interesting one. So that means that we don't see all those, useless events that we don't really know what they mean. We're just going to focus on the one that we do know what they mean. So that gives us enough information to go on. And you see that as soon as this happens, this bit transfer happens, we're going to hit that event. And it has nothing to do with whether the event log is active or not, right? So we got the event and we can report on it. Okay, so let's stop on that. So it has nothing to do whether it's active or not. So this is pretty cool because we are again working under the we're working below the level of the event logs. So that's that helps. So this is the example. Sysmon is another example. In Velociraptor, you can turn on the Sysmon, and what that does. So you can go over here and you can say, let's enable Sysmon. This is just an artifact like everything else, right? And when we select that artifact, search for Sysmon. And what that does is it will install Sysmon, and you can see that it's doing the same thing. It's watching the ETW feeds to forward those Sysmon events to the server. So it doesn't necessarily look at the log file itself, the EVTX file. It actually does it at a lower level. So it doesn't matter if the log file is disabled or whatever, right? So this is where it's more robust, I guess. Okay, so this is the example, right? So what we're going to do now is we're going to do an example to monitor DNS queries and understand where the DNS queries are coming from. So let's take a look at the DNS client, the DNS client which we looked at before. So let's go back to our reference here, and where was it? Windows DNS client. We might search DNS. There it is, DNS client. Okay, so that's the GUID, right? So we just simply do the same thing. We just select from that. So it's the same as this. We're just going to select for a different GUID, okay, and just watch it. All right, so it's going to go through and watch this thing. And what I might do is I might just generate some DNS traffic, www.google.com maybe. We'll do a ping. Does it do? Oh, yeah, it does something, right? So a lot of these events don't necessarily represent a DNS lookup, right? But there it is. So this event is a query, right? So somebody's querying for Google, and then we have some more things, and then we have some more. A lot of these things are related, but different. But some of the event types would be useful, right? So this one, and this one, and DNS server IP address, and so on, right? So, and then maybe this one has the results. So this one's probably kind of interesting, right? And the ID is 3020. So that has the results. And so there's as you can see, there's a lot of events that are kind of similar, but a little bit different. Which one did I end up using here? 3020, yeah. So that's the one I ended up using, right? So where system ID equals 3020, right? So that will give me a pretty good indication of which DNS queries are happening, right? So remember that sometimes they're caged, so I can, maybe find a different thing. See, so there's some more DNS queries that just happen to happen here, and that's the one that failed, and so on, right? So I'm getting good visibility on DNS that's going on right now. Okay, so that's ETW. It gives me ability to see the system, and and I can actually go and format the query a little bit better. So I have the query, I have the answer. It's kind of formatted a little bit easier for me to query on, and then I can turn that into an artifact. As you can see, just a client event artifact, and in fact, we already have one already kind of built in, so we can simply load it. So if we select artifact, search for DNS, you can see that we have an ETW DNS. That's actually what we're seeing here, right? The same one. So we don't have to type it, right? It's a bit easier. It's already built in. And when we launch it, then that will start to collect, DNS queries, right? And it's going to take, remember that when we collect it, it's got a little bit of a buffer. So it's going to take a few minutes to actually get the data. All right. I wanted to go through this exercise because this is a pretty cool exercise. And it's about parent process spoofing. Now, usually when we do this, there is a PS tree, which is an artifact that calculates the process call chain. Now, let me just quickly show you this artifact. Now, a call chain basically means that this process called this process called this process, right? So a lot of the time we use that to help us to try and detect like an exploitation attempt, because maybe we might have a rule to say like, oh, if PowerShell started off from Office, that's probably not great, so we can use that relationship between parents and child to what have we got here? Yeah, to basically detect anomalies, right? Okay, so what we could do, anyway, let's edit this one. Or we'll just do this one. Oh, wait. Okay, now it's this one. Let's delete some of those. Too many of them. Start deleting them. Okay, it's better. All right, so let's delete that one. Create another. Okay, it's already deleted. Yeah. All right, so what we can also do is we can select from other artifacts. So in this case, we're going to select from generic system PS list, and it just runs another artifact and then returns the value, the rows, as if it was a plugin, right? So that allows us to encapsulate generic system PS tree. If I just run this artifact, it's like collecting this artifact in the notebook. So it's going to show me, let me just limit it to maybe like the first 5 processes. It's just going to show me some of the process call chain here. So it basically follows the call chain, right? That's what the artifact does, where call chain matches Velociraptor. Okay, so let's see which call chain matches Velociraptor. So we can see that Velociraptor runs, is in these call chains, these two things, right? That's the PID, and that is the parent PID. So we probably got two of them running. So this is how it works, right? Explorer launches command prompt, launches Velociraptor. And sometimes we can use that to write some interesting detections. But it turns out that in Windows, parent-child process relations are fiction, because you can actually create any parent-child process you want, right? You don't actually have to, that is not necessarily true, right? You can create whatever you want. And that's been it started to be abused quite a lot by malware these days. It turns out, I mean, it's been known since probably forever, right? Like 15 years, people knew about this. This is basically very common knowledge. But I think in recent years, it's been more exploited. And so these kind of detections are not very reliable of process call chain. So here's an example of a tweet just the other day. I think it's got like, that today's date or yesterday's date, something like that, right? Where there's this is an exploit toolkit for macros, for a macro toolkit, and you can see that it launches the payload, and what it's doing is it's actually spoofing the parent PID, right? The parent process. So it usually what you expect to see is Excel launching Notepad. So you'll see like you're supposed to see Notepad as a child of Excel. But what it's doing is it's actually spoofing it and creating the parent is Explorer, not Excel. So this is it's actually pretty difficult to detect these kind of things, because when you look at a process, you really have no idea. Like if you look at the parent PID, according to at least what the API is returning, that is, it is what it's spoofed, right? So it's actually whatever the creator of the process wanted it to say. There's literally no limits here. So, literally, you can't really rely on process call chain. So here's an example, and I just wanted to show you guys so you can play with it. So there is this very old program here by D.D. Stevens. So it's just a proof of concept. You can grab that, download it, and it's just a binary. It's just a zip file. Now inside of the zip file, you'll find I mean, there's the source code and things, but here is the program, right? So we're going to copy it, put it in the downloads folder, right? So this is our binary. And what I'm going to do is I'm going to run process hacker, so I can see all the different processes. And in this example, what I'm going to do is search for Velociraptor. So here's Velociraptor running here, right? So it's just a process that happens to run on the system, right? But what I'm going to do is I'm going to show you how I can spoof the parent of a program using this select my parent program, right? So what I can do, so I have this select my parent, right? And if I just run it, it says start a program with selected parent process, and I have to give it the program and then the PID, right? So I'm going to start notepad.exe, and I'm going to make it look as though it came from Velociraptor, and the PID is 3088, right? So it will look like it's a child of Velociraptor. Of course it isn't, and has nothing to do with Velociraptor. But here's, here is my notepad, it started, right? But if I look here, it looks like notepad was launched from Velociraptor, right? Because it's a child of Velociraptor. And in fact, it's actually very, very difficult to tell that it isn't. all the APIs agree that it is that, right? It's actually not easy to tell how to detect this kind of spoofing relationship. Now, this is really important because a lot of EDRs use this process call chain to whitelist or blacklist these kind of attacks, right? And you can see that if a macro toolkit does that, then it really kind of defeats a lot of these kind of like heuristic based attacks, right? So attack detection. So how do we detect this? And this is the exercise we're going to do now, how to detect this kind of interesting kind of attack, right? So this is what we did, right? And even if we do our PS3 now, so here's our PS3 now. So we'll repeat that. We'll just recalculate this. And you can see that even Velociraptor thinks this is what happened, right? Notepad came from Velociraptor, right? Because the parent-child relationship is correct, right? So it's going through that. So that's a problem. How do we do that? How do we detect it? So it turns out that some smart people did some research and figured out that there's really only one way, reliable way to detect this spoofing behavior, and that is through this ETW. Because it turns out that when a process is created, there is an ETW event that is generated, and if you listen to that ETW event, then you can tell, but it only happens when the process is created, right? So you can't just come to a system that's existing and say, hey, what's the process tree look like? Because it's too late, right? It's only when it was created you can tell it. So you have to be listening for this ETW thing at the beginning. So it turns out that there is this Microsoft Windows kernel process provider. So let's take a look at it. So it's a kernel process, Microsoft Windows kernel process. That one. And that allows us to look at processes that are created and destroyed, and these kind of things. So this is the GUID. So let's just look at it. So we might just go here. Let's just create another notebook. Okay. All right, and create a Vql Cell, select star from watch ETW, GUID equals, that's the GUID, right? So let's watch this and see what happens. Now you can see, let's close this one and do it again. Okay, let's do it again. Yep, so we've just created another thing, and then we'll stop this. So there's actually like 900 rows. There's a lot of rows in here. What we're really interested in, and you can see that here, is that we only really care about, these are called keywords. We only care about process keywords. So you can use that to restrict the type of events that you're getting. So let's do that, because we're getting like far too many events, because they're like thread creation events and so on that we're not really interested in. So let's go any. So this parameter restricts the keywords. So we go over here and we just copy that keyword. See, the mask is OX10, right? So if we want to know about keyword only processes, then we have to give it a mask of OX10, right? So that's what this documentation is really doing for us. So let's do that thing, run the thing, and then look at the events that we're getting, right? So there we go. Stop. We got some events. Stop. Right. So what we are getting some events here. Oh, hold on a minute. Okay. Whoops. And we can actually, we don't have too much time, but we can actually follow these events. Actually, this is shit, this is not the right thing. I'm just gonna quickly show you guys how it's supposed to look like, because I think that is not the right event. So you can see that when this works, we actually have the version that I need to use is hasn't been released yet. It's in the I think it's in the master. Yeah, I haven't quite released it. We could probably download it from here. I think we'll have to log in. Yeah. Anyway, but what actually happens is that there is this this process ID is the process that's actually emitting this event. And the process that's emitting the event is the process that is the real process that's spawning that new command, right? So in this case, what we're seeing is we're running select my parent, right? In this case, and because select my parent itself is just a normal binary, right? Then it has the same process ID here and here. It's because it's the same, right? It's the same binary. But when it actually does this parent spoofing, right, then it launches. So select my parent. So this is the shell process that's launching select my parent. Select my parent itself will actually create. It will have a process ID, but the process that it's creating has a different parent. So this is the spoofing behavior, right? So you can determine the spoofing behavior by comparing these two fields together, and the description of that is in that F-Secure analysis, right? So they figured out that this is the way to detect spoofing, process ID spoofing. So it is actually quite an interesting. Now the query is going into quite a bit of details, which you could look at a little bit later, but essentially, it's about detecting the difference between the parent and child spoofing between these two fields that we've seen before to detect this spoofing behavior. And I'm not going to go into too much detail here about this, how we detect that, because there are some other problems, like processes are very quick, and so we can't really find the parent child. So we have these solutions here. But in the end, we end up with basically a detection for this parent-child spoofing behavior, which is actually quite difficult to detect otherwise. But using ETW, we can detect it. I just wanted to say a couple of limitations of ETW. And actually, ETW is super useful, and a lot of EDRs use ETW heavily. Like, for example, Sysmon uses ETW as well. But there's some problems with ETW which are not, it's good, but it's still limited. And it's actually, because it's not really, ETW is not really a security solution. It's really about debugging the system. And what we're doing is we're using ETW for security, but it's not really designed for it. One of the problems, there are basically two main problems with ETW. The first one is that there is a maximum number of sessions that you can have in ETW, and then you just can't create more. So that's obviously a problem, because an attacker can just create lots of sessions. And when they do that, then anyone else that wants to create additional sessions, they just can't. So it's a resource exhaustion type vulnerability. And then the other problem is that anyone can terminate an existing session as well. So you can just terminate a session. So let's have a look at this example here that I did. I'll just show you the screenshot because it's basically, that's what it looks like. Is that in here, we are just running a query that creates 100 listeners, 100 ETW listeners for this, this provider, some random provider. And you'll see that pretty soon, it exhausts that 64 provider limit. And then you just can't really attach any more providers. Like, they're all basically busy, right? And so that means that it's like a denial of service, right? Because if we're sitting there trying to listen to this kernel process provider, for instance, then we can't because the results exhausted, right? So an attacker can just simply set up a lot of ETW sessions and stop us from being able to attach to it. The other thing that we can do is you can just terminate a session. You can actually do this. You can actually do this in Velociraptor. So like if you go over to and collect an artifact, so there is a view session. View, where is it? Here. Whoops. View sessions. That allows us to just view all the different sessions. I mean, it just uses logran really, but you can actually view the sessions that are currently attached. And at the moment, we've got Velociraptor sessions. Actually, if you just, let me just copy that. By default, it has a filter, but let me just remove the filter. So match on dot on everything. And we'll be able to see all the sessions. You can see there's lots of sessions that are related to all kinds of stuff. And there's some of them are sysmon sessions as well, right? So sysmon, when sysmon is installed, it uses ETW. So we have sysmon DNS. This is the sysmon DNS one, which is exactly what we did in our exercise, right? This is what sysmon does as well, right? But it turns out that you can just kill those sessions, right? So you can go over here and turn on this kill matching, right? And just kill the sessions. And then that just can clean up all the sessions. So if sysmon is listening, right? And then you can just go and kill those sessions. And then sysmon can't hear any of those things anymore, right? So some of them are not going to work. But for example, like this sysmon DNS one, we were able to kill that properly, right? So if we go through and then just, let's not kill it, but let's just find it, then that sysmon ETW DNS one. So there's one that is still there, but the other one is gone. So for example, now sysmon can't hear any DNS queries anymore, right? So Velociraptor is aware that this could happen. And so it will actually restart the ETW sessions after they've been killed for itself. Like you see that we've closed off the Velociraptor once. And if we repeat this thing a little bit later on, that we should hopefully see the Velociraptor ones coming back. Or maybe it takes a little while. So this is the vulnerability, the problem in ETW. So it's good, but it's not that reliable, right? There's some problems with it. So this is just something to remember. Okay, so we only have like 5 minutes, I guess. And I have a whole other section, so we have far too much material here. But this is about server management. So I'm just going to like quickly describe to you what it's all about, and then you can maybe do it in another time. But we can also manage the server. So we can run VQL on the server. So we can manage large deployments using VQL. So an example is like counting how many clients and what do they do. How many types are of clients we have, like a Mac, Linux, Windows, counting those, and finding out how many clients were active in the last day, these kind of things. So these are this type of queries where you can group by OS and count how many clients are in each operating system, right? So these kind of things. But probably the coolest thing that we can do is integrate with Slack. And Slack is kind of a pretty common platform, and we can use that as like an escalation mechanism. And it turns out that Slack, so this is just an example of any kind of platform that has a REST API that we can talk with. So with Slack is the classic. It makes it very easy to do this. So let me just jump onto api.slack.com. And this is how we create an app in Slack So it's very easy, right? We go to the Slack and we create an app from scratch, right? We call it, pick a workspace, call it something, Velociraptor, right? And then we create that app. And then we just create a webhook like this. So we just turn it on. And then we click this new webhook. And we give it, let's say, a channel. So a webhook is just a way for someone to post to a Slack channel, right? But in the end, when that happens, it essentially creates this kind of URL, right? So it's just a URL, and you just call it. And so it turns out that Velociraptor can actually use these URLs to notify when something happens. So if we go to Slack and log on to our workspace, so launch Slack, and just open our workspace here. Okay, and then we are in the alerts channel, right? So we integrated this app. So it turns out that that all you have to do is replicate this post to actually, post to the channel. And once you can do posting to the channel, then you can use event logs, event queries to essentially post anything in response to, anything really. So this exercise kind of goes through and explains, how to do that. But this is what I just did, right? Created a webhook. But essentially, you just end up with, just a HTTP client is the Velociraptor plugin that makes HTTP calls. And there's nothing really special about Slack here. It's just something that has a REST API. And so Velociraptor can just make a REST API call and something can happen. So it's just like an integration with an external machine. So this is an example where we can go through the VQL and wait for whenever something happens. So it just shows us, in this case, when a client enrolls, and it basically sends us a Slack message when that happens. So you can look through it here and see how we develop the artifact, but also, but instead you can go to the artifact exchange here, and in the artifact exchange you can find all kinds of artifacts. And this is the one we're talking about here, the Slack clients enrolled, which triggers when a client enrolls for the first time, right? So it hasn't existed before. So it's very easy to use something from the exchange. You just copy it, then you just go over here and edit. Okay, so select all, paste, right, and then save it. So this particular one tells us when a new client is enrolled. This is usually very useful when you're doing a rollout, because then you can see when new clients are enrolled. So let's see how that was. So it's a server event. So it's an event query that runs on the server, and it watches for whenever something happens on the server. So we have to provide it with the token, so it can use that token to talk to Slack. This is the one we created here in the app. So we can just copy it. Like this, copy the token, right? And then we just go in here, and it's a server event, so we have to turn it on. Yep, so we'll turn it on here. So this is the same thing, but an event query that runs on the server. Okay, and we just select this, configure the parameters, right? So this is where the token is. We'll just paste it in there. That's our token. And then we'll launch it. And at that point now, you can see that let's just refresh that. The server, this query is running on the server. And so it's waiting for an event. Namely, the event is the clients are enrolled. So let's create another client. So again, we're going to create a new client. So now we have 52, so we'll enroll a new client. So when that happens, it will enroll a new client. And because of this query, when a client enrolls, it will send a message to Slack, right? So when we look into our Slack message, we've got our enrollment message, it appears. And this is an example of how to do escalation based on events that happen, right? And if you look at the slides further, we're doing other things like we are sensing for whenever, an endpoint, hits a particular domain, we can combine things together, right? And create these kind of alerts. So again, we don't have time to really get into that too much. But as we go along, okay. So we don't have time to get into it too much, but it gives you a bit of an idea as to what actually happens, how we can create alerts and escalations so we can go into Slack and automatically send messages to Slack. All right, so let's just conclude. So anyway, there is just so much that we haven't covered. We cannot cover everything, but I hope you got a bit of a taste to how Velociraptor can really be used, in a more advanced way, much deeper than just the usual collection, and particularly in monitoring and in deeper monitoring, alerting, escalating, and so on. So if you guys want to learn a bit more about Velociraptor, you can jump into, this is our docs documentation website, and then our GitHub, and we have a Discord channel. So if you have any questions, don't hesitate to jump onto the Discord channel or the mailing group, and feel free to ask questions and provide feedback, all that stuff. Cool. Thanks for coming. I guess that we sort of ran out of time a little bit, but if you guys have any other questions, let me know. Thank you. Cool, thanks.